Okay, so topic 15 is the introduction to quadratic functions. So we're going to look at the characteristics of a quadratic function and what the graphs of a quadratic function looks like. So here are some characteristics of a quadratic function. So a lot of vocab in the beginning. We already know that the standard form for quadratic functions is that ax squared plus bx plus c equals 0. If our quadratic function opens up, that means our a value or our parabola is positive. Okay, so if it opens up, a is positive. If it opens down, a is negative. And remember, a is that very first term in front of that x squared. The axis of symmetry is the line that divides the parabola in half. So right here, the important part for axis of symmetry is this formula. X is equal to negative b over 2a. That's going to find us the x value where we can draw that vertical line to divide our parabola in half. Next is the vertex. The vertex is either the lowest or the highest point on the function. So if we have a parabola that's facing down, then the vertex is that maximum right here at the top. If we have a parabola facing up, that vertex is at the bottom, the minimum. Okay, so depending on how our parabola looks is if we have a minimum or a maximum vertex. And then the formula for that is negative b over 2a. Notice that that first part is the formula for axis of symmetry, negative b over 2a. So once you find that axis of symmetry, you can plug in that value of negative b over 2a back into the function to find the y value of the vertex. Okay, and then the last four definitions are things that we've talked about in linear equations. So y-intercept is still the same. It's where it crosses the y-axis. If you see the word zeros, that is just going to be another name for x-intercepts. So zeros is another name for x-intercepts. On a quadratic function, we can have no zeros, 1 or 2 zeros. That's just depending on how many times it crosses the x-axis. And then lastly, the domain and range. The domain is the restriction of x values, and the range is the restriction of y values. Okay. So again, a lot of vocab in the beginning, but we're going to define all that in our examples too. Any questions on vocab? Okay. So on these examples, it's going to give us a quadratic function, and we are going to define each of the following. So for number 1, we're first looking if it opens up or down. So looking at the graph on 1, does it open up or down? Oh, it opens up. So just write up. Okay. The axis of symmetry is where we can divide this parabola in half. So the vertical line that can divide this parabola in half. So if we draw that vertical line here, our axis of symmetry is always going to be x equals. So what's that value of x? 0. So the axis of symmetry, the line that divides the parabola in half, is at x equals 0. Okay. And then looking at our vertex, do we have a maximum or a minimum? A minimum, because our point where the parabola turns is right here at the bottom. So it's a minimum. Okay. And that point where it starts to turn is called the vertex. So what point did I label the minimum?
0, -2.
0, -2. So that is our vertex. Notice how the value of the axis of symmetry, which was 0, is the first value of the vertex. That's always going to be true.
Can you repeat that, please?
Yeah. The value of the axis of symmetry, so in this case x is equal to 0, is always going to be the x value of the vertex. Okay, so those numbers should always match. So if in any case you're given the vertex, but they're asking for the axis of symmetry, even if you don't have the graph, you could say the axis of symmetry is x equals 0, because that's that first value of the vertex. Okay. Still got some parts here. So next we're looking at the y-intercept. So looking at our graph, where does the function cross the y-axis? Good, -2. How do we write that as a point? 0, -2. So that tells us that the y-intercept is the same as our vertex. Okay, that's not always going to happen. That was just a coincidence. Okay, next it's asking for the zeros. And again, the zeros are another name for what? The x-intercepts. So how many x-intercepts does this problem have? 2. So what are the 2 x-intercepts? Good. We have it at one at -1.5 because it's in between, and then one at +1.5. But we need to write those as points. So it's going to be -1.50 and 1.50. So the positive and the negative. Okay. Now it's asking for the domain and range. So when we are learning about quadratic functions, unless there are restrictions on the graph, what do we mean by restrictions? It stops at an open or closed dot. So unless we see those, the domain of a quadratic function is always all real numbers. So -infinity to +infinity. I'm going to write all real numbers, or you can write that fancy R. You could write -infinity to +infinity. They're all the same. You could write any of those 3 is correct. And then lastly, looking at the range, remember the range is all of the y values. So looking at the top part of the y-axis, does this graph ever stop?
No.
So that means it goes to infinity. But if we look down on the y-axis, where does this stop? -2. Is that included or not included? Included, right? Because that line of the quadratic is solid. Okay?
So would it be -2 comma infinity?
Correct. And then we remember that our -2 is included, so I have to have a bracket to infinity, and the infinities always have a parenthesis. Okay, so that was number 1. And we're just going to do this for the next couple problems to practice this vocabulary. Okay. So looking at number 2, does our function open up or down? Down, so we're going to say down. And at what value of x is our axis of symmetry? Where does it divide the function in half?
5.
Good, 5, right here. And that is at x equals 5. Okay. Looking at our vertex, do we have a maximum or a minimum? Maximum because it's at the top. And where we have the maximum is called our vertex, and that's at what point? Good, 5, comma 9. And again, notice that that axis of symmetry value is the same as our x value on our vertex. That's always going to happen. Okay. Now it's asking for the y-intercept. Do we see a y-intercept on this function? No, and that's only because of the graph that is limited to negative 11 to positive 11 on the y's. However, we know this function goes on forever, so will it eventually have a y-intercept?
Yes.
So what could we estimate our y-intercept to be?
12.
Good, we can estimate negative 12. So I'm going to write the graph is limited, right, because we can't see it. So possible is going to be 0, negative 12. Okay. What about the zeros? How many zeros does this problem have? 2. At what two values?
2, 0, 8, 0.
Good. 2, 0. So it crosses right here at 2, and then 8, 0. And remember, those zeros are the same as our x-intercepts. Okay. Next is the domain. I said the domain is always going to be what? All real numbers, because we don't see any restrictions on this graph. So all real numbers. Okay. And then lastly, looking at the range, looking at the top part of our graph, where does our y's stop?
9.
Good, at 9. And does it ever stop in the negatives? No, so that means I'm going to have negative infinity to 9. And am I going to have a bracket or a parenthesis on that 9? Bracket, because our parabola is a solid line.
So if it's a positive parabola, it's the number is going to be on the left side for the range?
Correct. Well, positive parabola on the left side, yeah. Just think of it as like the number for your minimum and your maximum, your vertex, is going to be the number you use in your range. Because notice on number 1, our vertex was 0, negative 2. And then on our range, we had negative 2 to infinity. Same with number 2, our vertex was 5, comma 9. So our range is negative infinity to 9. So we're looking at those y values.
So when reading the graph, I'm going to be reading from the top down, correct?
Or you can read from bottom to top. It doesn't matter as long as you put your negative number first.
Okay.
Your negative number is always going to come first. So if you want to remember it that way, then I would read it from bottom to top.
Negative number first.
Yep, negative number first. Any other questions? Okay, let's look at number 3. So first part, is it opening up or down? Down. What is our axis of symmetry? What value? 3. Perfect. Right here, where it divides the parabola in half. And axis of symmetry is always x equals. So x equals 3. Okay, is our vertex a maximum or a minimum? A maximum, because it's at the top. And it's a maximum at what value? What's the point? Good, 3, comma 4. And remember that the value of my x, my axis of symmetry is the same value as my x in the vertex. Does this graph have a y-intercept?
Yes.
Yes, at what point? Good, 0, -5. Right there is where it crosses the y-axis, so 0, -5. How many zeros does this problem have? 2, and at what numbers? Good. Good, so at 1 and 5. What's the domain of this function?
All real numbers.
All real numbers, always. And then looking at the range, what is our range going to be? Looking at our y values. Good, -∞ to 4 with the bracket, perfect. Because again, we know that these two numbers are always going to be the same. The y value of the vertex and the value in the range. Okay. So last one for this concept is number 4. So is this opening up or down? Up. What would our axis of symmetry be? Good, -2, because that's where the function is divided in half. Okay. And is it x equals -2 or y equals -2? X. It's always the x value. Is our vertex a maximum or a minimum? A minimum. And it's a minimum at what value? Good, -2, -5. And again, we know that these numbers are going to be the same always. Does this graph have a y-intercept?
Yes.
Yes, at what value?
0, -1.
0, -1. Yep. Right here at 0, -1. How many zeros does this problem have? 2, and at what values? Okay. Good, so notice that it's not quite at that 0. So we could say that's 0.25. And it's not quite on that -4, so we can say -4.25 or 0.3, 0.4, whatever gets close to that estimate. So this is okay. What's the domain of this function? All real numbers. And then lastly, what is the range? Good, -5 because of, let me write this here, -5 with a bracket to +∞. And that -5 came from the y value of the vertex. Okay, so that's how we define each of these parts by looking at a graph. Okay. However, you're not always going to get a graph. Most times you're going to get a function. So looking at the next part here, graphing quadratic functions, we're going to use the equation and all the vocabulary that we know, answer that, create a table, and use this information to graph. Okay. So we're going to answer all of the same things. So on number 5, we're looking at this function, f of x is equal to x squared minus 6x plus 13. So first part, you're telling me, does it open up or down?
Up.
Up. How do we know?
Your A is positive.
Good. A is positive. Okay. What would your axis of symmetry be? So remember, we do not have a graph this time, so that means we're going to have to be using our formulas. What was the formula for axis of symmetry? X equals negative b over 2a. So in this case, what is our b value?
6.
So our b value has to include that negative in the front, so that is negative 6. So we have a negative 6 over 2 times a. What's our a value?
1.
It's 1. Remember, if we don't see a value, we assume it's 1. So that minus a negative 6 turns into what?
Positive 6.
A positive 6. So we have positive 6 divided by 2, which is 3. So our axis of symmetry is x equals 3. Okay. So if we don't see a graph, we're going to go to our formulas. Okay. What was the formula for the vertex?
It's the axis of symmetry, comma, F, negative B over 2A.
Good. So what that is saying is we're going to take the axis of symmetry and plug it back into our function. So we know our first value of the vertex is 3.
Yes.
Okay? We need to plug that 3 into the function to find the y value. So we are going to do f of 3 is equal to 3 squared minus 6 times 3 plus 13. I'm plugging in the 3 into my function. So simplifying this, 3 squared gives me 9. Negative 6 times 3 gives me negative 18, and then plus 13. So I have 9 minus 18 plus 13, which is 4. Okay, so that means my vertex is 3, 4.
So that's what it is. When you're finding the vertex, you just plug in the axis of symmetry into the equation.
Correct.
Okay.
That's why those values are always the same for this and this. That's why they're always the same. Okay. Okay, next we need to find the y-intercept. And remember, the y-intercept is when we plug in what for x? What's the x value when we write y-intercept as a point? 0. So I'm going to be plugging in 0 for x. And when I do that, this is going to cancel. So that's 0 squared. This part's going to cancel because that's negative 6 times 0. So that means I'm left with what? 13. So if I'm looking at a quadratic function, it's always going to be 0, comma, whatever that last value is. 13.
Thank you.
Okay, now remind me, did we talk about factoring at all in this course? Not yet? Okay. Skip the zeros. Skip this part.
What are we going to talk about?
Probably the next couple notes. I'm thinking of the other course I already talked about factoring and not this course. Okay, so we'll come back to zeros later. The domain we know is what? Always
All real numbers.
all real numbers. Okay? And the range Since we're saying this parabola opens up, that means we're looking at the minimum to the tallest point. And remember that range is always going to consist of the y value of the what?
Of the vertex.
Of the vertex. So it's going to be 4 to,
Negative infinity.
or sorry, opposite. Negative infinity to 4, because our negative always comes first. Okay, and we found that 4 from the y value of the vertex. Okay. So now that we have all this information, we're going to create a table so we can sketch our graph. So x, y, okay. And I'm going to always plug in the same numbers here. I'm always going to plug in -4, -2, 0, 2, 4. You can choose any numbers, okay? When we're graphing a parabola, we know that some is going to be positive and some is going to be negative. So I always make sure I have 2 negative numbers, 0, 2 positive numbers. So again, you could choose any values for x. These are just the ones that I use. Okay. So in order to find the y values, what am I doing to these x values? Plugging them in. Okay, so to remember, our equation is this f of x is equal to x squared minus 6x plus 13. So if I plug in a -4, I have -4 squared minus 6 times -4 plus 13. Okay. So I'm going to go ahead and just plug that into my calculator. If you have your calculator with you, you're able just to plug in that whole thing exactly how it's written, and you'll get your answer. So it should be 53. Okay, so that means that point right here is -4, 53. Okay, now let's plug in -2. When we plug in -2 and put that into our calculator, we get 29. And then we already did the one for 0. Because if we plug in 0, that's the same as finding which intercept?
Your y-intercept.
The y-intercept. And we already said when we plug in 0, we got what number? 13. Okay. Then I'm going to plug in 2. And when I plug in 2, we get 5. And then lastly, I'm plugging in 4. And I get 5. Okay. So remember, these are all points. This is -4, 53, -2, 29, 0, 13, 2, 5, and 4, 5. So when we are sketching our graph, we're going to first plot those points.
Excuse me, Professor.
Yes.
I don't know what I'm doing wrong, but I'm punching that into the calculator and I'm not getting the same answers. Could you help me a little bit?
So
I'm putting in -4 squared.
are there parentheses around your -4?
No, I'm not sure how to do that on this. Oh, okay.
Yeah, so make sure you're typing all those parentheses as well. Because on your calculator, if you do -4 squared, it's going to square the 4 and bring down the negative.
Oh, okay. So, try that.
Okay, so while you're doing that, let me know, and I'm just going to plot these points.
Yeah, that's weird how the parentheses make a difference.
It's because your calculator can only do so much, you know? So in these type of calculators, if you just put -4 squared, you're telling the calculator square the 4, which is 16, bring down the negative. But if you put parentheses, then it's like, oh, you want to include the negative in this? Okay, negative times a negative is a positive, and that's how you got the positive 16. Okay, so I'm going to plot my y-intercept, which was at 0, 13, so I'm going to assume it's up here. And then I'm going to plot my vertex. What was my vertex for this problem? 3, 4. So I'm going to say about right here. And then I'm not going to plot that -453 because, again, it's just too far off the graph. Same with that -2, 29. It's too far off the graph. But I can plot that 2, 5 and the 4, 5. And I can plot my axis of symmetry. So where is my axis of symmetry on this graph?
3.
At 3. So if I draw this line down, I know that my parabola is going to be equal on both sides. So I can start drawing my parabola like this. Okay. So looking at this parabola, what do you notice that's different versus the first 4 that we did above?
It's wider.
Okay, it's wider. Anything else you notice?
Oh, no, X.
There's no x-intercepts. Why? Good. The graph never crosses the x-axis, so there are no zeros. So we could use that information, go back up to part E, and say no real zeros. Okay. So for this part, we are going to be using that graph we find to establish our zeros until we learn how to factor. Okay. So we would go through all those steps to graph a quadratic function from scratch. Okay. There will be a problem like this on the test. Okay. Let's look at the next one, number 6. So looking at number 6, we're looking at this function here, -x squared minus 2x minus 1. So looking at that, does it open up or down? Down, and how do we know? Good, because A is negative. This is A. What is the axis of symmetry?
Maybe.
Remember, we have a function, so we have to use a formula. So what's the formula?
X equals negative b over 2a.
Okay, in this case, our b value is what? -2, so we're going to have a -2 because of our formula. And then on the bottom, 2 times a, what is our a value? -1, remember, because of that -1. So a -2 turns into a +2, and then on the bottom here we have 2 times -1, which is -2. So that means our axis of symmetry is x equals
0.
-1. 2 divided by -2 is -1. So that's our axis of symmetry. How do you use the axis of symmetry to find the vertex?
Plug it in.
Plug it in. So we have f of -1 is equal to negative, parentheses, -1 squared, because we're plugging it in for x, minus 2 times -1 minus 1. Okay. So negative 1 squared is 1, but we have that negative in the front, so we have negative 1, so this is negative 1. Negative 2 times negative 1 is 2, so plus 2, and then minus 1. So we have negative 1 plus 2, which is 1. 1 minus 1 is 0. So that means our vertex is going to be at what point?
Negative 1 comma 0.
Negative 1 comma 0. Without doing any math, just looking at our equation, what is our y-intercept? 0, negative 1, because it's always going to be 0 comma that last value. Negative 1. Skipping the zeros for now. What is always the domain? Okay, all real numbers. And the next question is the range. What do we use for the range? What value?
Vertex.
The vertex. Which value in the vertex?
0.
That's 0. And it's opening down, so that tells you it's going to go towards positive or negative infinity.
Negative.
So that means we have negative infinity and 0. Which comes first?
Negative.
Negative infinity. Always those negative numbers first. Then we have a bracket on the 0. Okay. Now we're going to create a table. And remember, I just used those same numbers over again. So negative 4, negative 2, 0, 2, and 4. Just because I want some negatives and some positives. So I'm going to rewrite the equation here so we have it. And I'm plugging in a negative 4, negative 2, 0, 2, and 4. So I'm plugging in all these values in for x. So the first one I have negative, parentheses, negative 4 squared, minus 2 times negative 4 minus 1. What'd you get? Okay, 23. Everyone else get the same?
You want to check?
I'm trusting you here. 16 negative plus 8 minus 1. It's actually negative 9.
Negative.
Everyone else get negative 9?
Yes.
It's negative 9.
You think you checked?
Now I'm going to plug in negative 2.
Use your parentheses.
Right here.
Oh, no, for when you do those.
So for this one, we should get, so that's negative 4 plus 4, 0, negative 1. Everyone get the same? We already found the 0 one. When we plugged in 0, we got what? Negative 1.
Yes.
I'm going to plug in my 2 now. So I'm going to get negative 4, negative 4, negative 8, negative 9. And then I'm plugging in my 4. Negative 25, get the same. 16 negative.
Trust me, okay?
Well, I think I'm wrong, though. I think I'm wrong. Minus 8,
No way.
minus 1. No, I'm right. Negative 25. Okay. Again, these are our points. Okay, and now we're going to take this table and create our graph. So the first thing I'm always going to graph is the y-intercept. What's my y-intercept here?
0, negative
0, comma, -1. Okay, then I'm going to plot my vertex. What was my vertex? -1, 0. Okay. Then I plot my axis of symmetry. Okay, which is going to go straight down here. Okay. And then I start plugging in some points from my table. So I have -4, -9. So 2, 3, 4. I'm going to say that's down here. Then I have -2, -1. Remember, this is just a sketch. I already have the 0, -1 on there. So I have 2, -9. And then 4, -25 is going to be off my graph. So I'm not going to plot that point. We know that our function is going to be pointing down. So it makes sense that our parabola in this case is also going down.
And would the only x value be that -1, 0?
Correct. So in this case, we only have 1, 0, and that's at the vertex, which is -1, 0. So if I go back up to the zeros here, looking at my graph, I now know that I have the 0 of -1, 0, which is the same as my vertex. Okay.
So what are those first three things that you plot?
You always plot the y-intercept.
Okay.
Okay. Then you plot the vertex. Then you plot the axis of symmetry. And then any other points off your table. Okay. Once we figure out how to factor and find our zeros, the zeros would be another thing you would plot. And the order of that doesn't matter. As long as you are plotting those things, you're going to get your graph. Okay, so we have 2 more problems here. So we're doing the same thing. We now have the function -x² plus 4x plus 3. So looking at that function, is it going to open up or down? Down, and how do we know? That negative in front of the x². What's our formula for axis of symmetry?
X equals -b over 2a.
Negative b over 2a. In this case, what is our b value? 4. So I'm going to write a -4 over 2 times what? What's our a value? -1. So I have -4 divided by -2, which is 2. So my axis of symmetry is x equals 2. Let me rewrite that. How do I use my axis of symmetry to find my vertex? Plug it into the original problem. So I have -2 squared plus 4 times 2 plus 3. Okay. So 2 squared is 4. Bring over that negative. That's a -4. 4 times 2 is 8 plus 3. So it's -4 plus 8 plus 3. 7. Which means that my vertex is what point? 2, 7. What is my y-intercept? 0, 3. How did I find that? Yep, it's the whatever number's at the end. So in this case, it's the 3. We're going to skip zeros for now and go to domain. Domain is always all real numbers. Okay, and then our range, we use what value from the vertex? The y, so it's going to include a 7 in it. And since it's opening down, is it going towards positive infinity or negative infinity? So what's our range?
7, negative. Oh,
Close.
negative infinity.
Yep, negative infinity, comma 7. Negative has to come first.
And they'll always have that, like,
Yes, on the number will always be a bracket. Okay. For this course, yes. Okay, now we're going to create a table. And again, I'm going to pick the same values. And I'm going to rewrite my function so I have it down here. Okay, so I'm going to be plugging in all these values in for x. So that's what I'm going to be writing here. Plugging them all in for x using my parentheses. So even when you type in your calculator, use your parentheses. Right now I'm just writing them down. So the first one should have got negative 29. Then negative 9. We already knew the y-intercept, so that's why I just wrote 3. Negative 4, 8, 4, 7. 16, negative 16. 16, 0, 3. Okay. Everyone get the same? Definitely a good idea to practice this on your calculator to make sure you're getting the same ones as me. That means you're using your calculator correctly. Okay. So again, creating that table gives us extra points to plot. So once we have all this information, we're able to graph. And what's the first thing I should graph?
Your y-intercept.
Y-intercept. And what's my y-intercept?
0, 3.
0, 3. Okay, then I should plot what? What's next? The vertex, which was 2, 7. I'm going to say it's all the way up here. Okay. Then I draw my what?
Axis of symmetry.
Axis of symmetry. And then I go back to my table and plot some points. Am I going to plot that first point, negative 4, negative 29?
No.
No, it's too far off the graph. But I can plot negative 2, negative 9, which is going to be, let's say this, down here. Okay. And I already got that 0, 3. I can plot 2, 7. I already did. 2, 7. And then 4, 3. Okay. So we know that this graph is facing down or opening down. So it's going to look something like this. Okay. And since this is a sketch and we're not able to name the exact zeros, I just want you to tell me how many zeros will this problem have?
2.
2. So if I go back up to the part where it says zeros, we're going to say 2 real zeros. And what I mean by 2 real zeros is that they're going to be actual numbers that cross at the x-axis. Okay, so that was number 7. And again, on the exam, I would want a really rough sketch like this. As long as I see that you're plotting some points, rough sketch. Okay. And then last one, number 8. We are looking at the function negative 3x squared minus 30x minus 82. So looking at part A, is it opening up or down? Down, and we know that why?
It is negative.
Good, there's a negative in front of the x squared. For part B, what is my formula for axis of symmetry? Good, negative b over 2a. What is my b value here? Negative 30, but since my formula also says negative b, I'm going to write a positive 30, because negative and a negative gives me a positive. And then I do 2 times my a value. What's my a value? Negative 3. So that means I have 30 divided by negative 6, which is negative 5. Good. So I have x equals negative 5. That's my axis of symmetry. How do I find my vertex? Plug it in. I'm plugging in negative 5. So I have negative 3 times negative 5 squared minus 30 times negative 5 minus 82. Okay, so we should have got negative 7. Is that correct? Okay. Meaning that our point is going to be
Negative 5, comma, negative 7.
negative 5, comma, negative 7. That is our vertex. Without doing any math here, what's our y-intercept?
0, comma, negative 82.
Good, 0, comma, negative 82, because whatever that last number is, we're going to skip the zeros for now and look at the domain. Domain is always what? All real numbers. And for the range, we're looking where?
Your y value of the vertex.
Good, so our y value of the vertex, which is negative 7, and this is opening down, so it's going to be continuing on to the
Negative infinity.
negative infinity. So we put negatives first, but since there's 2 negatives, we put our larger negative first, which is going to be
Infinity.
negative infinity. So we have negative infinity, comma, negative 7, bracket. Okay, then we create our table with the same values. And I'm going to be plugging all those values into my equation negative 3x squared minus 30x minus 82. So I'm going to go ahead and write that out first. And then we already know that when we plug in 0, we get negative 82. Now I'm going to start plugging this into my calculator. So the first one, we should have got negative 10. 4, negative 34. Negative 154. negative 250. So again, that tells us we're not going to be plotting a lot of these points. They're not going to be on the graph. But just so we have them, here's our points. Okay, our x and our y values. And now we're going to start our sketch. So first thing I'm plotting is my y-intercept. However, my y-intercept, well, that's okay. I'll still plot it. So 0, negative 82. Let's say this point is negative 82. So there's my y-intercept. Then I'm going to plot what point? The vertex. And what was our vertex? Negative 5, negative 7. Let's say that is here. Okay, then I plot my axis of symmetry right there at negative 5. And then I see what other points I can plot. So I could plot that negative 4, negative 10. So let's say right here. And I can plot that negative 2, negative 34. Again, this is all a sketch. So knowing that it opens down and my parabola is symmetric, it's going to look something like this. And what does that graph tell you about the zeros? There are no real zeros. So the reason I'm writing no real zeros is because there is such thing as imaginary values. But we don't talk about those in this course. I don't think so. No real zeros.